Hello everyone. Today I want to explain about the trigonometric identities. Trigonometric identities is one of the complicated chapter, odd concept in 10th class. So student need to learn trigonometric identities easily. So for that purpose, today I am going to tell you one small technique to write some identities in trigonometry. So basically we know that, for example, if sine theta is equal to 3 by 5. So find tan theta is equal to what, or cot theta is equal to what, and cosec theta is equal to what. So like these questions we'll do in 10th class. So for this purpose we will take a right angle triangle. So this is ABC right angle triangle, right angle at B. So we are observing from C, there I will write the theta. So you know that sine theta is equal to opposite by hypotenuse. So opposite should be the 3 and hypotenuse should be the 5. So for that purpose you want to find the BC by using the Pythagoras theorem. After getting the value of BC, you can write the tan theta, cot theta, cosec theta values. So while you are writing the BC, these are the ratios. 3 by 5 is the ratio of sine, but AB is not equals to 3 units and AC is not equals to 5 units. Actually, the ratio between the opposite and hypotenuse is 3:5. For that purpose, we will take the one constant, that is 3x and 5x, or 3k or 5k. So after that, k value also will be cancelled. So by using this concept, how to write some trigonometric identities easily. So for that purpose, here I have taken one right angle triangle. So theta is at C and B is 90 degrees. Then we can call AB is the opposite and BC is the adjacent, and by the way hypotenuse is AC. So my concept today is one of the important question in trigonometry, that is convert all trigonometric ratios in sine terms, convert all trigonometric ratios in cot terms, convert all trigonometric ratios in tan terms. This is very complicated to every student to write the trigonometric ratios in the given ratio. So for that purpose, today I am going to teach you one small technique, how to write the trigonometric ratios in given trigonometric ratio. For example, I want to convert all trigonometric ratios in sine terms. I want to convert all trigonometric ratios in sine terms. I want to write cos in sine terms. I want to write tan in sine terms. I want to write cos in sine terms. I want to write cosec in sine terms. I want to write sec in sine terms. So while writing these formulas, a student will get some complication and sometimes he will do some mistakes also. For this purpose, I will tell you a small technique. So for example, this is my triangle. Now I want to convert all trigonometric ratios in sine terms. So according to my figure, sine theta is equal to, you know that sine theta is equal to opposite by hypotenuse. According to my figure, opposite is AB and hypotenuse is AC. Now sine theta by 1 is equal to AB by AC. If you let AB is equal to sine theta and AC is equal to 1. Actually, I want to multiply with one constant. Otherwise, if you multiply also, at last it will be cancelled. So just I have taken AB is equal to sine theta and AC is equal to 1. What happened? Let us see. So AB is equal to, here I wrote it is sine theta, and AC I have taken as, hypotenuse I have taken as 1. By Pythagoras theorem, BC square is equal to AC square minus AB square. This we know very well. Adjacent square is equal to hypotenuse square minus opposite square. So now BC square is equal to AC. AC is equal to 1 square minus AB is equal to sine square theta. Now BC square is equal to 1 minus sine square theta. Now BC is equal to under root of 1 minus sine theta. Now you see the 1 minus sine square theta. Now you see the magic. So now BC I got as under root of 1 minus sine square theta. You see now. Now I can write all trigonometric ratios in sine terms. That is, the first one is cos theta. Cos theta is equal to adjacent by hypotenuse. Now adjacent I got under root 1 minus sine square theta by hypotenuse is 1. So cos theta is nothing but under root of 1 minus sine square theta. I got it. Cos I wrote in terms of sine. If I want to write tan theta is equal to opposite by adjacent. That is equal to opposite. We have taken as sine theta by adjacent. We got it as 1 minus sine square theta. So now tan theta is equal to sine theta by under root 1 minus sine square theta. For example, if I want to write the cot theta is adjacent by opposite. So cot theta is equal to adjacent I got as under root of 1 minus sine square theta by opposite I got it sine theta. So cot also converted into sine terms. For example, I want to write cosec theta. Cosec theta is equal to hypotenuse by opposite. So hypotenuse, you know that is 1 I got, and opposite I got as sine theta. You know that cosec is the reciprocal of the sine. By my technique also I got cosec theta is equal to 1 by sine theta. If I want to write sec theta, that is sec is equal to hypotenuse by adjacent. That is hypotenuse I got 1, adjacent is I got as under root of 1 minus sine square theta. If I clear the board, directly you can understand what I wrote here. Sine theta is sine theta, and cos theta I wrote here, where I wrote cos theta is equal to 1 minus sine square theta I got, and tan theta is equal to sine theta by under root of 1 minus sine square theta, and cot theta I got under root of 1 minus sine square theta by sine theta. Cosec theta I got 1 by sine, and sec I got 1 by under root of 1 minus sine square theta. So like this, I converted all trigonometric ratios in sine terms. For example, sometimes he will ask you convert all trigonometric ratios in terms of tan. Just you want to do one simple technique here. If you apply the same technique, you can write everything in tan terms. I mean, every trigonometric ratio you can write it in tan terms. For example, same triangle I will take here. Tan theta is equal to, you know that, opposite by adjacent. So according to my triangle, opposite is AB and adjacent is BC. Now tan theta by 1 is equal to AB by BC. Therefore, if you say AB is equal to tan theta and BC is equal to 1, so AB is equal to, this is tan theta, and BC I got 1. So by Pythagoras theorem, you know that this is tan square theta plus 1. If you apply the Pythagoras theorem, the hypotenuse value will be tan square theta plus 1 under root. Now you can convert all trigonometric ratios in tan terms. Sin theta is equal to opposite by hypotenuse. My opposite is tan theta, and hypotenuse is under root of tan square theta plus 1. Cos theta is adjacent by hypotenuse, that is equal to 1 by under root of tan square theta plus 1. Tan theta is tan theta, cot theta is equal to adjacent by opposite. You know that 1 by tan theta, this is the reciprocal ratio between these two, and cot is 1 by tan. Or cosec theta is equal hypotenuse by opposite. Hypotenuse I got under root tan square theta plus 1 by opposite I got tan theta. So like that you can write the sec theta. Sec theta is equal to hypotenuse by adjacent. So hypotenuse I got under root of tan square theta plus 1 by uh, adjacent is 1. So this is sec theta is equal, this is our identity only, under root of tan square theta plus 1. So like this easily we can convert the trigonometric ratios according to the given ratio. This is one of the simplest technique to write trigonometric ratios according to the given ratio. Thank you.